Good morning, sir.
Good morning, class.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning,
Good
sir.
morning, sir.
Is the screen visible?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so we have completed till this. Okay, shall we move to the next problem? Okay, that is next problem is use the theorem on residue at infinity. Evaluate the integral of each of these functions around the circle. Okay, this is the problem. What is the theorem on residue at infinity? Yeah, this is the theorem. What is given in the statement? Gayatri. 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 Yes, what is given in the statement? Your robotic voice is good, but it is not clearly audible. Kaviyarasi.
Sir,
Hmm. What is given in the statement, ma?
sir, function f is analytic everywhere in the finite plane
Hmm.
except for a finite number of singular points, sir. That is
Hmm.
integrated to a positively oriented simple closed contour.
Hmm.
If this so, the integral value is 2 pi I residue 0 z equal to 0 1 by z square f of 1 by z.
So this is what we'll have to do, right? So in order to evaluate the integral, it is enough to find the residue of this function at 0, and that function is 1 upon z squared multiplied with f of 1 upon z. Okay, here in the statement it is very well given that your function is analytic everywhere in the finite plane, which means this function must have only a finite number of singularities in the entire complex plane, right? And if the singular points are lying inside some simple closed contour, then you can evaluate your integral in this station. This is given, right? So you will have to identify such a simple closed contour such that it contains all the finite singular points. Sometimes you may have a countable number of singular points. In that case, can we say we have only finite number of singular points? Let me repeat my question. Suppose you have a countable number of singular points. For example, consider the function 1 upon sin z. Okay, let me just write here. So consider the function 1 upon sine z. Okay, this is my function. What are the singular points to this function? Singularities of this function. Prasanna Devi.
Sir,
Singularities of this function. When will your sine z equals 0?
0.
Only at 0. What about sine pi? Sine 2 pi?
आप ही और हूँ सर.
You said only 0. What about the other points? Shalini.
Sir,
What are the singular points of this function? That is, I am asking for the points at which sine z becomes 0.
n pi sir.
N pi. Good. So singularities of f of z are n pi with n pi with n can take any value in the set of integers. Okay, what kind of set z is that is your integers? Is this countable or uncountable? The set of integers is a countable set or uncountable set?
Countable.
Countable set. So it is countably finite or countably infinite?
Countably infinite, sir.
Countably infinite. So to this function, you cannot make use of this theorem. Is that clear?
Countably infinite.
Okay. So guys, is that clear? To such kind of functions, you cannot make use of this theorem because this function has a countably infinite number of singularities in the entire complex plane. Right? Whatever may be the closed contour that you take, it will not cover all your singularities inside it. So first of all, you must be very clear with to what kind of functions we can make use of this theorem to identify the, to evaluate the integral value. Is that clear? Guys, is that clear?
Yes sir.
Yes, sir.
Yes sir.
So here, using the theorem, we are asked to solve this. The theorem tells us that integral over c f of z dz is nothing but 2 pi I multiplied with residue at z equals 0 to the function 1 upon z squared multiplied with f of 1 upon z. So first of all, we will have to verify whether the given function has only a finite number of singularities or not. Okay, let us now evaluate the singularities of this function. Right? What are the singularities of this function? What are the singularities? Kanish,
1.
Sir,
what are the singularities?
Z cube is equal to 1. Z is equal to
Which means that equals,
try.
sorry, I didn't get you.
1 will repeat 3 times.
Is that so? Is it true in complex numbers?
Mm.
I am asking for complex roots of unity.
Okay.
Sanjita?
Sir, आप 1 omega
Sir,
omega.
Yes, yes, Kanishka has answered it. 1 omega and omega square. What is omega? Minus 1 plus or minus I root 3 upon 2. Am I right?
Yes,
See
sir.
guys, if you are asked to find out here what you are doing is that from which you can very well write c equals 1 to the power 1 upon 3. So when it is so, you are having a unit circle, and this unit circle has to be split into three parts starting from this origin, right? So starting from the origin, you will have to divide this into three equal parts. So let us take this as our origin. So this is the point. So from here, it is complete 360 degrees. You will have to divide that 360 degrees into equal three parts, means 120 degree each. So 120 degrees, 120 degrees. Is that clear? This is how we divide. This point is 1. It is very well clear that it is the point 1. Okay, for all nth roots of unity, you will have 1 as one root. The other roots, you will have to find this point and this point, that's it. So it is 120 degree. It is, if you measure this way, this is minus 120 degree. So you know z can be written as cosine theta plus I sin theta, and I have given you your theta value. So it is cosine 120 degree plus I times of sine 120 degree. So in the other way, either you can substitute 240 degree or minus 120 degree. If you do so, you will get these values. This is how we get these values. I have written plus or minus, which means it is same as that of your omega square as well. If you choose plus in this case, you will have minus in omega square. If you choose minus quantity in omega, then you will have plus quantity in omega square. This is how we calculate cube nth roots of unity. Is that clear? Guys, I asked, is that clear?
yes, sir.
Yes, sir.
If you want me to repeat the same thing, just tell me, sir, repeat, please. Repeat. You just tell me that. I'll do it. I have no worries in repeating things. All I need is that you have to understand these ideologies. Okay? So this is 1 omega and omega square. Here, what is the contour that we have chosen?
Absolute of z
In this
equals to
problem. Yeah, good. So if you choose this as your 2, this is some bigger circle of this form. Okay, now tell me whether all our singular points are lying inside this or not. All the singular points of this function are lying inside this or not.
Yes, sir.
Yes. Is that clear? Because all these points are lying on the circle absolute of z equals 1, which is inside absolute of z equals 2. That is why we can very well say that all the singularities are lying inside this. Here, all these singular points lying inside absolute of z equals 2, and this function has only 3, which is a finite quantity. Singularity in the entire complex plane. So we can say either entire complex plane or finite plane. Therefore, integral over c f of z dz is 2 pi I residue at z equals 0 to this function. Now tell me, what is f of 1 upon z? What should we do in order to find f of 1 upon z?
Instead of z, we have to take 1 upon z, sir, the function.
That's it. So 1 upon z to the power 5 upon 1 minus 1 upon z cube. So it is 1 upon z power 5 multiplied with 1 upon. So when you take the LCM, it becomes z cube minus 1 upon z cube. So as a whole, this becomes 1 upon z power 5 multiplied with z cube upon z cube minus 1. Am I right?
Yes, sir.
So this is simply 1 upon z square multiplied with z cube minus 1. So this is what we have. So now we'll have to multiply 1 upon z squared with this, which is 1 upon z squared multiplied with 1 upon z squared with c cube minus 1. Right? So now I'll have to find out the residue of this function about that at the point z equals 0. So what I do is that I take 1 upon z to the power 4. If I have 1 minus some quantity, I can expand it in Lorentz series. Now I have z cube minus 1. What should I do now? What should I do now?
Sir, changing the sign, sir.
That's
Minus.
it. So let me take minus outside, so it becomes 1 upon 1 minus z cube. So I have 1 upon z to the power 4, and when I give the expansion to this, I would get 1 plus z cube plus z cube square plus z cube to the power 3, and it goes this way. So this is how it goes on, right? So minus 1 upon, so when I multiply this quantity inside, so I would get 1 upon z to the power 4 minus 1 upon z plus it is z to the power 6. So it is minus z squared minus z to the power 5 minus etc. So this is what I get. So now tell me, what is the residue value?
-1, sir.
That's
Minus
it.
1.
So this quantity is nothing but minus 1. Therefore, integral over c f of z dz is nothing but, you will have to multiply that residue value with minus 1. So that is minus 2 pi. This is our integral value. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, as usual, I'll have to make some changes here, right? The first change that I am doing is z to the power 5 upon 1 minus your roll number. If you have understood the concept, it just take 1 minute, hardly 1 minute for you to complete this problem. If you just understand the flow of this problem, you can just answer it in like within a seconds you can answer this. Let me see who answers. I need only the answer. Don't give me the explanation unless I ask.
Minus
The
2
same
pi.
-1.
Okay, you are giving me the residue value or the integral value?
Now integral value, sir.
The residue value -1 and integral -2 pi I.
Okay. Okay, let others think. So for roll number 18 and 36, it is the same answer.
सबके लिए सेम ही आएगा ना सर?
For 17 also, it is the same.
So -1 -2 pi I தான் சார் வரும்.
Okay. For 41 also, it is the same. For 29 also, it is the same.
சரி எல்லாருக்குமே அது
எல்லாத்துக்குமே
Why? Why?
ஏன்னா அதோட கோபிஷியன்ஸ் வந்து பார்த்தீங்கன்னா -1 நம்ம -1 பை சம்திங் மல்டிப்ளை பண்ணும்போது எல்லாத்துக்குமே -1ல தான் இருக்கும்.
Sorry, I didn't get you clearly.
இப்போ இருக்கிற சம்திங் நான் சொல்றேன் -1 பை z⁴ அந்த சீரிஸ் பண்றோம். அந்த சீரீஸ்ல எல்லா கோஎஃபிஷியன்ட்டும் 1 1 தான் இருக்கு. ஆனா -1 பை சம்திங் அந்த z⁴ பவர்ல இருக்கிறத மல்டிப்ளை பண்ணும்போது எல்லாரோட கோஎஃபிஷியன்ட் மைனஸ்லயே தான் வரும். அப்ப பண்ணும்போது அதோட ரெசிடியூ கன்ஃபார்ம் -1 தான் வரும்.
Okay. Guys, is that clear to everyone? See, in order to apply this theorem, what you have to check is that whether your given function has only a finite number of singularities or not. This is what you will have to check first. Okay. Now, for your problem, you will find rth root of unity. Anyway, all the rth root of unity is going to lie on the unit circle only, right? That is, of course, lying inside the given circle, that is absolute of z equals 2. Okay, the hypothesis of the theorem is satisfied, hence you can very well apply this theorem, right? Whatever may be the thing, you just do all this stuff and you can very well see you are getting -1. Okay, if you have cube, it will go to the numerator, and whatsoever the thing is, you will get all the things to be same. But I have a doubt whether you will have every one of you are getting -1 only. You are not getting 0 for anyone. I have a doubt over that. So if we just do this calculation here, it will be better. Let me just do it for the general case.
அது r less than 5 மட்டும் தான் இது நான் -1 வர்றது. r less than அந்த நியூமரேட்டர்ல இருக்கிற 5க்கும் டினாமினேட்டர்ல r-க்கும் கம்பேரிஷன் வச்சு வரும். கம்பேரிஷன்ல ஒண்ணுக்கு -1 இன்னொன்னுக்கு எல்லாத்துக்கும் 0 வரும்.
So that is what I was just asking. So this 1 upon z to the power 5 multiplied with z to the power r upon 1 minus, sorry, z to the power r minus 1. So this 1 upon z to the power 5 minus r minus we take outside, so 1 upon 1 minus z to the power r. So when we give the expansion -1 upon z to the power 5 minus r, so it is 1 plus z to the power r, z to the power 2r, and it goes this way. So make sure that you are getting something in the denominator. If you have to get something in the denominator, so you must get 1 upon z, right? So substitute your roll number here and see. Either you will get -1 or 0. Not every one of you will have -1. Okay. Now I am just changing a little bit in this problem. Take this as today's task and you will have to complete it. Okay. Now let me move to the next problem. The function is 1 upon 1 plus z squared. What are the singular points it has?
Plus or minus side.
Plus or minus I. Yes. Okay. The singular points are whether it satisfies the hypothesis of the theorem or not.
Yes, sir, it satisfies.
Yes. So it satisfies the hypothesis of the theorem. So integral over c f of c dz, this may be written as 2 pi I residue at c equals 0 to the function 1 upon z squared f of 1 upon z. So your f of 1 upon z is what? Am I right? Guys, am I right?
Yes, sir.
Just do the expansion and tell me what is the residue value. Tell me the residue value. Hmm? Guys, you just give the expansion. Instead of z, you have z squared. That's it. So it is going to be 1 minus z squared plus z to the power 4 minus z to the power 6 plus z to the power 8 minus etc. What is the coefficient of 1 upon z in the expansion?
0, sir.
So the residue value is 0, which means your integral over c f of c dz is also 0. Is that clear? Is that
Yes,
clear?
sir.
Yes,
Yes,
sir.
sir.
Okay. So the next problem. What is the singular point? What is the singular point?
0, sir.
0.
0, 0.
So the only singular point is 0. Therefore, it also satisfies the requirement of the theorem. Therefore, you can very well write this as 2 pi I residue c equals 0 1 upon c squared f of 1 upon c. What is f of 1 upon c?
C, sir.
Z, sir.
Z. Therefore, 1 upon c squared f of 1 upon c is
1 by
what
One.
is it?
1 upon Z.
1 upon c. So residue at z equals 0, 1 upon c squared f of 1 upon c is what?
1, sir.
1.
1, sir.
1.
Therefore, your integral value is what? 2 pi I. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now I am giving you an exercise. I think you don't have to do it afterwards. You can do very well now itself. R upon S plus C squared. This is your f of c. Right? Here it is S upon R multiplied with C. Take down all these three problems and do it now.